In 1970, General Motors put $50 million behind an engine that had no pistons, no connecting rods, and looked nothing like the V8 engines Detroit had spent decades perfecting. This wasn't a forgotten concept car. Chevrolet was preparing to sell this thing to ordinary Americans. Engineers were designing future cars around it, and one of the wildest Corvettes ever built would eventually carry 4 rotors behind the driver. Then, just as GM seemed ready to bet on the future, the entire program disappeared. No production engine, no rotary Chevrolet, $50 million, and nothing in the showroom. So what went so badly wrong that America's biggest automaker killed an engine it once believed could change everything? This is Motor Memento, where America's automotive past comes back to life. Subscribe, and let's find out how GM's $50 million bet disappeared. By 1970, Detroit had spent decades refining the piston engine into something close to a science, so when the Wankel rotary showed up, it looked like something from a different era entirely. It was small, light, had a fraction of the moving parts of a conventional engine, ran with a smoothness pistons couldn't match, and packed real power into a surprisingly compact housing. GM wasn't alone in noticing. Automakers around the world were circling this technology. And General Motors didn't just study it, they bought into it. In 1970, General Motors secured the rights to develop Wankel rotary technology in a deal widely reported at roughly $50 million. That was the kind of number a company commits when it believes it has found the future. GM didn't intend to simply buy finished rotary engines from someone else. The plan was to design and manufacture its own rotary power plants, in-house, at scale. And the first Americans expected to encounter GM's rotary wouldn't necessarily be driving a Corvette. Chevrolet had its sights set on the Vega. The plan was to offer a rotary-powered version for the 1970s, and that decision tells you everything about how seriously GM was taking this technology. This was rotary power heading straight for an ordinary, everyday American driveway. Picture that for a second. Had it worked, an entire generation might remember rotary Chevrolets the same casual way they remember a small block V8 or a dependable inline-six. As GM worked through the engineering and regulatory hurdles, the production timing kept shifting. For now, understand this. The rotary Vega wasn't a rumor. It was close. Remarkably close. A conventional V8 takes up a lot of room, and that footprint dictates everything else about a car: where the weight sits, how the cabin is packaged, how the vehicle is proportioned. Shrink the engine down, and suddenly designers have room they never had before. GM was considering cars that could become fundamentally different because of that engine, and nowhere did that idea go further than with the Corvette. This is where the story stops sounding like a business decision and starts sounding like science fiction. Chevrolet built genuine rotary-powered Corvette concepts, first a two-rotor version, then a far more dramatic four-rotor concept that combined multiple rotary units to produce serious output. Think about that leap. GM had gone from planning a rotary engine for a budget-friendly Vega to building one of the most radical Corvettes Detroit had ever created, using that same underlying technology. If you enjoy the forgotten decisions that almost changed American cars, this is exactly the kind of history Motor Memento was built to dig up. So if you haven't already, go ahead and subscribe, because GM's rotary story is about to get a lot more expensive. At this point, everything about GM's rotary program looked like the future had already arrived, but making a rotary fast enough for a Corvette was not the same as making one clean, efficient, durable, and cheap enough to sell to millions of Americans. That's where the story turns. Quickly, so the rest of this makes sense. A conventional engine moves pistons up and down, and a crankshaft converts that back-and-forth motion into rotation. A rotary skips that step entirely. A roughly triangular rotor spins directly inside a specially shaped housing, creating the same intake, compression, combustion, and exhaust phases a piston engine needs, just through a completely different motion. That's what made it compact, that's what made it smooth, and that's also what made it difficult to seal. The tips of that spinning rotor rely on what are called apex seals to hold compression as they sweep around the housing. Sealing a moving triangular shape inside a curved chamber is a very different challenge than sealing a piston inside a straight cylinder, and engineers ran into real trouble. Gas leakage, seal durability, and intense thermal stress concentrated right at those edges. It would be easy to say bad seals killed GM's rotary. That's too simple. This was a stack of interconnected problems, and every one of them needed to be solved at the same time, because waiting behind sealing and heat was something even bigger. Early rotary engines could deliver strong performance from a small package, but they burned fuel doing it. Government testing found rotary-powered vehicles could use noticeably more fuel than comparable piston-powered cars. That was manageable in 1970, when gasoline was cheap. Then came 1973. The oil crisis rewired how American buyers thought about their cars almost overnight. Fuel economy went from an afterthought to the single most important question a driver could ask. And GM's engine of the future had just developed its worst possible weakness at exactly the moment America wanted to use less fuel, not more. American emissions regulations were tightening fast, right as GM tried to bring the rotary to market. The shape of the rotary's combustion chamber made it harder to burn fuel completely, which created real difficulties with hydrocarbon emissions and demanded serious exhaust aftertreatment to compensate. GM now needed this engine to be clean enough, efficient enough, durable enough, and affordable enough to build, all at the same time. Every problem GM solved seemed to reveal another one waiting behind it. Here's the part most people never hear about. General Motors was built around manufacturing conventional piston engines at massive scale, faster and cheaper than almost anyone on Earth. Rotary engines needed different tooling, different machining, different processes entirely. Period assessments suggested rotary production should be considerably slower and more demanding than the piston engine lines GM had already perfected. The rotary looked small inside a car. Inside a GM factory, it was starting to look like a much bigger problem. The rotary Vega didn't disappear all at once. It slipped, quietly, gradually, one delayed deadline at a time, while engineers kept working through problems that refused to stay solved. GM had already spent the money. The Corvette concepts existed. The plans had been announced publicly, but the production date kept sliding further into the future. In 1974, General Motors finally stopped moving the deadline. It killed the program instead. There wasn't one single failure that ended it. It was the whole equation: emissions requirements, poor fuel economy, sealing and thermal issues, manufacturing complexity, ballooning development costs, and a market that had changed completely since 1970. GM could still improve the rotary. What the company could no longer prove was that improving it was worth the money. But this story has 2 more chapters left. The four-rotor Corvette concept didn't vanish with the engine program. The body survived. The rotary power plant did not. That concept eventually evolved into the Aerovette, and it wore a conventional Chevrolet V8 under that dramatic bodywork. The futuristic Corvette, built to prove GM could move beyond the piston engine, survived by accepting the very kind of Chevrolet V8 the rotary was supposed to make obsolete. American Motors Corporation had designed its upcoming Pacer with a rotary engine in mind, expecting General Motors to supply it. When GM's program collapsed, AMC was left holding a car engineered around an engine that no longer existed. The Pacer ultimately went into production with a conventional inline-six instead, a much larger engine than the compact rotary the car had originally been built around. GM's cancellation didn't just end a Chevrolet program, it reached across the entire industry and reshaped another automaker's biggest gamble too. GM's $50 million rotary gamble wasn't foolish because the technology had no potential. It failed because potential wasn't enough. By the time General Motors needed the engine to be clean, economical, durable, cheap, and ready for mass production all at once, the world had changed underneath it. The rotary Chevrolet disappeared, the Corvette went back to V8 power, and even AMC was left redesigning around an engine that never arrived. So here's what I want to know. If GM had held on just a little longer, do you think the rotary Vega ever makes it to a real American driveway? Let me know what you think in the comments. If you enjoy the forgotten decisions that almost changed American cars, subscribe to Motor Memento, because Detroit's history is full of futures that never made it to the showroom.